Professor Black Ops. You see it. Let's get it. Facebook is down. Mark Zuckerberg, come on, man. Let's go over it. I'm gonna do it from a cybersecurity review standpoint. So a couple people asked me to do it. So let's kind of walk through it like it's from a cybersecurity standpoint. Facebook outage. We all know. Facebook owns a number of properties. These are some of the biggest ones: Instagram, WhatsApp, Oculus, Lenovo, and Beluga. So the three big properties that I'm aware of that was down was Facebook, Instagram, and WhatsApp. And those are three big, huge social media properties owned by Facebook. So let's go over it. So um, one of the cloud vendors that monitors the internet, they actually keep track of all the outages of major media companies. This is all the Facebook properties that were out in red, right? So of course, United States, Canada, South America, some parts of Africa, Europe, right? Uh, Middle East was down. So that you know how really big Facebook is. When I actually checked on their infrastructure years ago, I think somebody said they had 50 to 70,000 servers spread around the world, the planet. Because half the I think they said half the world's population was on Facebook, and those three properties, probably almost up to 60 or 70% of people social media use those properties. I mean, that's how big Facebook is down. So when they're out, right, that's a huge issue. So let's talk about an incident response playbook, right? From a social security uh, review, a playbook is you need to respond quickly to detect security attacks, to contain them and remediate its damage. New widespread cyber attacks happen. Microsoft will respond with detailed incident response guidelines. That was Microsoft's playbook I was looking at. You also need to detail guidance for common attacks. Malicious users employ every day to address this need using an incident playbook for these attacks. Each playbook has prerequisite, the specific requirements you need to complete before starting an investigation, including logging, workflow, the logical flow that you should follow to perform an investigation, a checklist, a task of steps in a flowchart. The checklist can be helpful in a highly regulated environment to verify what you have done in the investigation steps. Detailed step-by-step guidance for a specific investigation. So your playbook is meaning you practiced it, right? So they should have practiced some kind of worldwide outage to do what? Who do you notify? Who gets called? Facebook's so big. Is it the United States Facebook, Europe, right? I'm sure they have um, staff in all parts of the globe, right? So when it's big enough, I'm sure all that stuff rolls up into the United States into a central cybersecurity event, and it gets rolled down to the countries of how you're going to handle those events. But you got to practice that, right? You got to figure out that reporting requirement. You got to figure out that call tree, right? And that's big enough, right? Somebody need to be calling Mark Zuckerberg if he's in the bed on holiday in another location somewhere, that worldwide outage, right? He's gonna get a call for that. Then, from an incident response perspective, like what would you test? Like we talked about, if everything goes out, what's the call tree? Rolling back network patches, right? We're gonna get to that as part of the root access calls. Was actually a patch on a router, right? A/B testing. Facebook is so big they can roll out a patch just to the United States, right, or a smaller country, test it, and if something happens to it, they can roll it back. That's why it's called A/B, right? I can go B in a couple smaller countries, test this rollout, then roll it out to bigger countries, right? Then logging, right? Are we logging everything we need to track the outage, the hack, or whatever it is? right? You need to have logs, a centralized logging, because they have probably a petabyte of logs every day because they have so much traffic, right, and so many different objects. And once again, the three pillars of cybersecurity is confidentiality, availability, or integrity. Right? One of the first things Facebook said is, and we're going to look at that once again, I keep saying that, is they were not hacked, they didn't lose any data, right? So confidential integrity is good, right? But availability, because you got to remember when that's happening, those routers are going down. You don't know if it's a DDoS attack. You don't know if it's ransomware. You don't know if it's 4 or 5 countries trying to take you out, right? So when it's going on, you got to figure out what's happening. So operations is doing some things, and the cybersecurity group's doing some things, right? Too is sometimes it's called a bump and pick pop, right? Or they causing all your networks to go down around the world while they're stealing your database with all your information, all your credit cards, all your, your your data, right? Because Facebook's a data company, right? They get paid off all the ads, right? But all those ads, what you click on when you watch it, where you checked in, it buys phone data to match their data, right? To triangulate where you were at. So all that data is worth some money, right? So, but they figured out very quickly it was an availability issue, right? So one of the things we just talked about is we figured out what it is, right? We figured out what's happening. Now we got to figure out a root cause, right? It's called RCA, root cause analysis. Root cause is defined as a factor that caused a non-conformance and should be permanently eliminated through process improvement. The root cause is the core issue, the high-level cause that sets in motion the entire cause and effect reaction that ultimately leads to a problem. Right. The reason you want to know the root cause is like just to stop it, to put something in place so it won't happen again. If you don't know what really happened, you can't put in factors to stop it from happening in the future. Right. So anytime anything happens in an organization, at the end we always says, what is the RCA? What is the root cause? So we can figure out, do we need to check something? Do we need to make something patch? Do we need to put something in? If this situation happens again, shut down this particular rack of routers and switches, right? But you need to know the root cause so you can figure out how to prevent it. So this is a synopsis of what happened. Said Monday's hour-long outage of Facebook and its sibling sites, including Instagram and WhatsApps, resulted in 14 million reports from users who were unable to use social network apps and other services. The outage also reported result in losses of $60 to $100 million in terms of revenue, while the service disruption also impacted the Facebook stock, which fell by 4.9% on Monday. That 4.9% fall in the stock translated to a $47.3 billion in lost market cap, right? So somebody's probably going to get fired up for this, right? When your company loses $4.73 billion in a 6 hour period, right? A market cap. And also the revenue of 660 and $100 million, right? That's a big issue, right? So they need to figure out the root cause and make sure it never happens again. But let's be honest, that's a drop in the bucket for Facebook, right? Facebook prints money. Let's see, the outage was triggered by a system managing our global backbone network capacity. I'm going to repeat that. The outage was triggered by the system that manages our global backbone network capacity. The backbone and network Facebook has built to connect all computer facilities, which consists of tens of thousands of miles of fiber optic cables crossing the globe and linking all their data centers. Right, so all their data centers is hooked up, dark fiber, underwater cables, millisecond response, right? So they're controlling they try to control all their own cabling, right? Because they want to control the capacity and outages. The data center comes in different forms. Some are massive buildings that house millions of machines that store data and run the heavy computation load that keeps our platform running. Others are smaller facilities that connect our backbone network to broader internet and people using our platform. right? So Facebook, once again, has huge, small, medium, large. They got data centers around the planet. Let's just say it like that, around the planet. Like some with millions of machines in it, right? Millions of racks and racks and racks of machines. This was the source of yesterday outage during one of our routine maintenance jobs. A command was issued with the intent to access the availability of a global backbone capacity, which unintentionally took down all the connections on our backbone, effectively disconnecting Facebook data centers globally. Our systems are designed to audit commands like these to prevent mistakes like this, but a bug in an audit tool prevented it from properly stopping the command. So that's what the incident playbook was saying is we need to figure out what the bug was in the audit tool to stop that command, right? So was it the wrong command or did the command they run started to change reaction? So the audit tool should have just stopped it from running, right, as a system job. So that's in red. Our systems are designed to audit commands like these to prevent mistakes like this, but a bug in the audit tool prevented it from properly stopping the command. One of the jobs performed by smaller facilities to respond to DNS queries. The DNS is the address of the book of the internet, enabling small web names we type into the browser to be translated in a specific IP address. Those translation queries are answered by our authoritative name servers that occupy well-known IP addresses themselves, which in turn advertise the rest of its internet via another protocol called Border Gateway Protocol (BGP). Right. So on the root cause analysis, it said that PGP command cascaded through the whole backbone. And without the PGP command, the internet can't see your DNS tables. Right. So that was the root cause of it, was that PGP command. So what is PGP? It's a postal service of the internet. When someone drops the letter into the box, the postal service processes the piece of mail, chooses the fast and efficient route to deliver the letter to the recipient. Similarly, when someone submits data across the internet, PGP is responsible for looking at all the available paths that the data could travel and picking the best route, which usually means hopping between autonomous systems, right? So PGP is the link. Once again, it's the mailboxes from different autonomous systems, and it links them all together. I have a diagram of that. PGP is the protocol that makes the internet work. It does this by enabling routing on the internet. When a user in Singapore loads a website with the origin of the server in Argentina, PGP is the protocol that enables the communications to happen quickly and efficiently. Right, so it's hops, right? So you can go around the planet the other way, right? Or go just across the street, right? So PGP is the addressing to make sure you get the shortest distance and the quickest time, right? So what is an autonomous system? The internet is a network of networks. It's broken up into hundreds of thousands of smaller networks known as autonomous systems. Each of these networks is essentially a large pool of routers run by a single organization. So that's the picture of how the autonomous looks, and BGP handles traffic in that diagram right. And two is going to go hopefully through the quickest location. That's what the PGP does. So like again, once it doesn't center around the planet, it handles that addressing, right? And it's supposed to be able to figure out the shortest rounds of hops. Going to each one of these autonomous systems is a hop, right? So you want to minimize those hops. Who operates the PGP system? Autonomous systems typically belongs to the ISP or other large technical organizations, such as tech companies, university, government agencies, and scientific organizations. Each autonomous system wishing to exchange routing information must have registered an autonomous system number. Internet Assigned Number Authority assigns ASN to the regional registry, which then assigns them to ISPs, and network ASNs are 16 numbers between 1 and 65,534 and a 32-bit number between those. As of 2018, there are approximately 64,000 ASNs in use worldwide. The ASNs only require for external BGP. And the BGP externally is the internet. All right, so once again, when that PGP went down with the addressing, those are all the Facebook properties that were down. Okay, we talked about the root cause analysis, the RCA. Once again, we kind of talking about from a cybersecurity issue and not more of a operational issue, right? BGP we know was the bad protocol. Like they said, the audited PGP failed, so they need to make sure they get checked in their audit tools so it wouldn't happen again. Update the incident response playbook. So as you went through in real time, it's called a postmortem. So what worked in your communications, what didn't work, how can you speed it up so if it happens again, you can get it fixed in less than 6 hours? Once again, we hoping that out of the PGP fails so it'll never happen again. But if another patch or something happening, how can you speed up that process? How can you speed it up so you know it's a PGP issue and that's it? All right. Incident response team. Who did you call? Did everybody get notified? Did every government agency get notified? Did everybody state agency get notified? Do you have personal contracts with bigger companies that you have to let them know that you're down, right? Because Facebook helps a lot of businesses. Sometimes you might have an interchange agreement between a company that's sharing your data, right? So they want to be notified maybe within an hour or two. So, right, did that response team make all that communication, time, teams, right? Could you figure out quick enough it's PGP availability, but it's not a cybersecurity attack, so you won't be spinning cycles with the cybersecurity team. I'm sure the database team is trying to figure out what's happening, right? Because I'm sure when they lost track of the internet, they had some calls that went to other companies, so they didn't know if it was the database, the OS, or the routing, right? So all those teams got spun up, right? So we're trying to figure out how to make that less of cycles for each of those teams. Go over to other switches, right? Since those bad switches internally cause the PGP issue, could there be some way where it could figure out that patch was bad and it rolled over to another switch that was good? Right. And once again, are there legal responsibilities for other businesses that are lost, right? All right, from our legal team, are we going to get sued? Who do we need to let know? Did we violate any government regulation, state regulations, city regulations, or business contracts we signed up, right? So from a root cause analysis, all those boxes needed to be checked. But once again, we're talking from a cybersecurity perspective and not a operational perspective. Once again, I just kind of wanted somebody asked me actually to do it right. So once again, Facebook's down. Mark Zuckerberg, come on, we got to do better. Once again, if you have any questions, just put them in the comments. Professor Black Ops, cybersecurity for the people. Please subscribe.